In this video, we'll be looking at the topic Introduction to Data Communication, and this will be our first video on the lecture series on data communication. At the end of this video, you should be able to briefly explain what data communication is and why it is important in our modern society, and then you should also be able to identify and then describe the various components of a very simple communication system, and then explain the characteristics of an effective data communication system, and then also be able to explain the various data flow modes: simplex, half duplex, and then full duplex, and then also be able to describe a very basic communication process using the Shannon-Weaver system model. So let's begin. So what is data communication? We refer to data communication as the process of transmitting data between two or more devices through a transmission medium. The keywords here are data, and then transmission medium, and then devices. So data communication is just the process whereby you send data from one device to the other device, or from one or more devices through what we call a transmission medium. The data can be in a form of text, numbers, images, audio, or video. So that is the basic definition of what data communication is: just transferring of data between devices that is passing through a transmission medium. We will try to explain what these keywords mean later in the later slides. Others also define it as the exchange of data between a source and a destination through a communication channel using agreed protocols. So here also the keywords here are source, destination, communication channel, and then protocols. The source is the sender, the destination is the one that receives the data, and then the communication channel here, in the first definition we said transmission medium, and in the second definition is communication channel. They are all representing the same thing. And then we have another keyword here called protocol. So in the next slide, we'll try to explain what these keywords that we have mentioned in our definition mean. If you understand them, then it will be easy for you to put the definition in your own words. So just understand that data communication is just the process of transferring data from one device to the other through a transmission medium or through a communication channel. So the transmission medium here that we talk about, or the communication channel, can either be wireless or wired. Wired means it is passing through some sort of a cable, or wireless means it is passing through the air to the next device. And then we have some types of wired mediums. The cables, we have different types of cables, and then the wireless as well. We have different types of wireless media, which we'll be looking at in our subsequent lecture. So this is a typical example of a communication system. We can see here, for instance, we have a smartphone here, and if let's say the smartphone wants to access something from the server here, the smartphone has to send the request, and the request, these dashed lines are representing the wireless media. It's passing through the air to the Wi-Fi device here, and then these straight lines in the diagram here are representing the wired media. So this wireless media, the data passes through, gets to the device here, and then it passes through these cables, passes through this cable to a device called a switch here before it passes through the cable to get to the switch, to the server, and then the server will respond with whatever request that this smartphone made. So this is a typical communication system where data is moving from one device, which is the smartphone, to another device, the Wi-Fi to another device, the router to another device, the switch, and then finally to the server. So that is the basic explanation of what we mean by data communication. Just the transfer of data from one point to the other, and that happens through a transmission medium, which can be a wireless medium or which can be a wired medium. This is also a typical example where someone is accessing a smartphone and then connecting to the main telephone company. See, the smartphone or the cell phone connects to the mast, the antennas on the mast through the wireless transmission media, and then the tower also connects to the station through a cable. We'll look at the types of cable used, and then we'll look at also the types of wireless medium that devices connect to each other later. And then this is a typical satellite communication system, which is also a data communication system. We have the main satellite transmitter here, and then we have various satellite receivers on the building. So the transmitter will transmit whatever data that it has for the receivers through the wireless media. And this is also another type of wireless media that we'll look at later. Let's look at why data communication is important. I think by now, looking at the images in the previous slides, you should now understand why it's important. They are foundational to internet services, to mobile communication, to banking and e-commerce, cloud computing, Internet of Things. Now we cannot do without data communication. At every point in time, we are sending one or more data from our devices to the next device somewhere. So data communication is foundational to our way of life now. And in all these things that I've mentioned here, data communication happens. So this is the basic reason why data communication is important. And then you should understand some basic things about how data is transferred from one point to the other. So without data communication, modern digital systems will not function. If we don't have data communications, our data systems don't work, and then there is no form of communication between devices. So back to the terms that we mentioned in the definition. We mentioned that it's the transfer of data between devices. We know data is defined as raw fact that you are sending, and then information is when the data is processed to make meaning. So the devices along the way can process the data to derive meaning out of that data. That is when we call it information. So if there is no meaning to what we are sending, it is data. And then when it gets meaning out of it, it's processed, then we can call it information. So basically, these terms are sometimes interchanged, and then it's normal as we go along the way. If we mention data at some point in time, we might not be able to really differentiate what we are saying, whether it's information or whether it's data, but it's sometimes very commonly interchanged, and that is normal. And then let's look at what a network is. A network is just interconnection of devices, like what we saw in the previous images. Devices connected either by wireless medium or by a wired medium. We call that a network. And then a node, we just talking about any device that is connected to the network. So, and then these devices here are all nodes. That is what we mean by a node. And then we have what we call a channel. A channel is the medium used for transmission. So it's the same as the transmission medium. So you can either say transmission medium or channel. So the channel can be wireless or wired, and then the same transmission medium can be wired or wireless. So you can interchange these two words. Either you use transmission medium or you use the word channel. They are all the same. And then in the second definition, we also saw the word protocol. Protocols are just set of rules that governs communication. So in data communication, if you hear the word protocol, we are just looking at the rules that devices have agreed upon to communicate. That is all. Now let's look at the component of a very basic communication system. So in any communication system, we should have what we call a 5 essential components. These are basic. It can be broken down into more, but we'll look at the basic component. We call the first one the sender, and then the sender can also be called the source. This is where the device initiates communication. For example, if you have a smartphone, or if you have a computer or any other device, and then you want to communicate with somebody, you are the one sending the information. So your device becomes the sender. That is the simple definition of the sender. Is the device that starts the communication. And then 2, we have the message. The message is the actual data you are transmitting to the other device. This data can be in the form of text, audio, video, images, etc. And then the third one is the transmission medium or the channel. By what means is the data leaving your device to the next device? Is it through a cable or is it through the wireless medium? That is what we call the channel or the transmission medium. And then it's stated here that the physical path through which data travels, for example, are the copper cables, fiber optic cables, and then the wireless medium. So as we've explained. And then we have what we call the receiver. Others also call it the destination. Sometimes it is split apart. We have receiver and then we have destination, but this one is put together. That's why we're saying this a simplified component for the communication system. So the receiver is the device that receives the message that the sender sent. Example can be any device at all, because one device at the end can be, at the sender can be any device, and then the other device at the receiver can be any device at all. And then the last component that we have is what we call the protocol. So this protocol is not a device. It's not something that can be seen, but these are rules that all the devices that are involved in the communication, whether they are 2 devices, 3 devices, any number of devices that are involved in the process of sending and receiving, they have to agree on certain rules for communication. For example, they have to agree on the format of the data. How should the data be formatted? The timing. When are we sending the data? Error handling. How do we handle errors in the data that we are sending in case there is error? How do we deal with that? And then flow control. How much of the data are we sending at a time? How much can the next device receive? Should I send bit by bit or can I send all of them? That defines flow control. And these are the basic things that protocols set rules on. So we say that protocols, these are the rules that will govern how devices communicate on a network. So these are the 5 components of a communication system. The basic one, basic component, there are 5. That is what we've looked at. Now, this picture portrays how protocols works. So in the first device 1 and device 2, they have the set of rules and they agree on this set of rules that this is how we'll communicate before the communication will start. So before, in the communication system, before communication starts, the rules are already agreed, that the protocols are in place, and then data can flow. So we have an example here to explain the component of a communication system. So for example, when you want to send an email to your friend, your laptop becomes the sender, that is the device, the sender. The message becomes the content of the email that you are sending, and then the medium. Is it over the internet? Yes, if it's over the internet, then it can pass through wired channels, or it can pass through wireless channels. If it's on your local area network, it's the same thing. It can go through wired channels, or it can go through wireless channels. And then we have the receiver, which is the recipient device, the person that you are sending the email to. The person's device is the receiver. And then common protocols we can use, or that is used on the network for email services, is the simple mail transfer protocol, we call the SMTP, and then the transmission control protocol / internet protocol, we call the TCP IP. So now that we know the basic component of a communication system, if a communication, should a communication be effective, then we should be looking at some things here. Delivery. Data must reach the correct destination. If I'm sending something to a specific device, then that specific device should be able to receive what I sent. That's an effective communication system. If you send something, it doesn't go to a different person. It goes to the same device that you wanted to send something to. And then the accuracy, data must be delivered without errors. Ideally, that is what we aim to achieve, that the data should get to the receiver end without any error. And then because of this, error detection and correction mechanisms will be in place along the communication channel to ensure this. So the third thing for an effective communication system is that data must arrive on time. So if you are watching a real-time video online, or playing a video game with somebody online, or having a telemedicine service, your data between the sender and the receiver must be on time for these services to work. Assuming you are watching a video live and then there's so much delay, it doesn't fit the purpose. Or a doctor is examining you from a different country, and then the doctor cannot see exactly what he or she is examining, and there is delay in the transfer of data from your device to his or a device, or from his or a device to your device. It doesn't make the communication system very effective. That is one. And then jitter. Jitter is also a form of, is just on the timeliness that we are talking about. But there's a more technical word. Let me explain the jitter with a real example. We are saying that jitter is the variation in packet arrival. Now, we can replace the packet with data arrival. Packet, or as we know, is at the layer 3. We'll go into that later on. So the variation in packet arrival means that if you are the sender and there is a receiver somewhere, if you agree on transferring data, let's say that you are having a telemedicine service where a doctor is in Japan and you are in your own country. Let's say that for the data for the telemedicine service to be successful, your data should move between the two devices, let's say within 1 millisecond for the service to work. Or let's say that you are watching a real-time football match. The data from the video camera in that stadium to your phone or laptop should be 1 millisecond for you to enjoy the service. Jitter means variation. So this time, instead of the data moving 1 millisecond to your phone, it can move 2 millisecond. And the next time it can move 3. The next time it can move 4, counts back to 1, goes to 6, to 10. It makes the service very, very bad. And then it affects how you get your data, and then it affects your service. So that is what we mean by jitter. How the arrival time of packets vary in real time. That is what we call jitter. And then in the slide, it stated that it affects your voice calls. So you can hear a person, and the next time you cannot hear the person after some time, and next time you cannot hear him after a long time, and you can hear him, and then that is just bad. So we've talked about the effective communication system. Let's look at the data flow modes. Now that we have a fair idea of the components that make up a communication system and why data communication should be effective, let's look at how data flows between devices. Basically, there are 3 common ways that data flows between devices. And then these modes are the simplex communication, the half duplex communication, and then the full duplex communication. These are the 3 basic ways through which data moves from one point to the other. So we'll explain these 3. In simplex, what we mean by simplex is that data flows only one way. It doesn't return. So if you set up a communication system, the data moves from only one direction to the other. It doesn't return. A typical example is a television broadcast station. I'll draw a very simple television broadcast station here. Let's say that this is the television station, and then there is a presenter here, and then there's a video camera here that is videoing the presenter, and then the data moves to a transmitter here, and then the transmitter has antennas that will broadcast the data, so that if you are in your house, there's a simple house, your TV is here, you can sit here and then watch the presenter as the presenter is maybe broadcasting the news. With this communication system, it's the simplest communication system because data moves from here to here all the time. The communication system is such that, okay, you should also have your antenna somewhere here that connects to your TV so that you can get this data. So the data moves from the TV station system to your TV set, and then it is not vice versa. It doesn't happen like that. So in a typical communication system like that, that is what we call the simplest communication system. Another example is also the radio broadcast, where a radio presenter sits at his or her radio station and then broadcasts something to us. It is always only in one direction. That is the meaning of simplex communication. And these are 2 examples we can have here. So the image here shows 2 devices, and then one device sending the information in one direction, this device cannot send back. That is just one-way communication. And then we have what we call the half duplex communication. In half duplex communication, communication happens in two ways. That's it. There's a two-way communication. Device 1 can send to device 2, and then device 2 can send to device 1. But it doesn't happen simultaneously. That is the key word. If we say simultaneously, we mean it doesn't happen at the same time, where both of them can send at the same time to each other. It doesn't happen like that. Device 1 have to send. When device 1 is sending, device 2 will wait. After device 1 has finished sending, before device 2 can also send back to device 1. So they don't do it at the same time. They wait for their turn before they can send data to each other. So that is the meaning of device 1. That's the meaning of half duplex. A typical example is the walkie-talkie. With the walkie-talkie, if you've seen how it is used before, a person speaks into the walkie-talkie and then will wait. All the others will wait before they can also speak in turns. In walkie-talkie, we don't speak at the same time. That is the example. And then the third one is what we call the full duplex mode. In full duplex mode, both devices can communicate at the same time in the opposite direction. So both the transmitter and then the receiver can send data at the same time. Example is your telephone calls. If you are making a call on your mobile phone, you can speak, and as you are speaking, the next person can also speak. The person you are speaking to can also speak, and then you can hear both yourselves at the same time. You don't have to wait for someone to talk before you can talk. Both of you can talk at the same time. And then that is an example. So in our video conferencing, for instance, you see yourselves at the same time. You can talk to each other at the same time. So you can have more examples of full duplex, a communication that happens simultaneously at the same time. So this is an example of a full duplex communication. Normally, our modern computers, laptops, and the modern devices have full duplex communication capabilities. So lastly, we'll look at a very simple communication system called the Shannon-Weaver communication system. The Shannon-Weaver communication system was developed by two scientists, Shannon and then Weaver. They sat down to build this simplified model. We have more complex models in data communication, but this is a very simple model and widely adopted. So with the Shannon-Weaver communication system, they proposed that for every communication system, we have these components. We have a transmitter. We have a source. We have a transmitter. We have a channel. We have a receiver, and then a destination. And it has been nicely depicted in the diagram below, where the source is the source of information, the device that initiates the data process. And then we have a transmitter. So the data is passed on from the source to a transmitter, and a transmitter is just the device that will send the data. And then as the data goes, the data is represented by a signal. In our next lecture, we'll go into details of what signals are. And then here becomes our communication channel or transmission media. The channel is passed to the communication channel or the transmission media. And then inside the channel, noise is introduced inside the channel. And then we'll go into details of what we mean by noise in our subsequent lecture. Finally, the data gets to a receiver, and then the receiver also passes it on to the destination device. So this is the model Shannon-Weaver proposed as the communication model. And this is the basic model that we've looked at. So these things, component here, should not be missing out of any communication system that you build. Yeah. I've already explained this. So let's briefly go through. The source generates the data. The transmitter converts data into signals before it goes onto the channel. So for example, the network interface card of your laptop will convert the data into signals before it transmits. The same thing with modem. And then the channel is the medium that carries the signal. The receiver converts the signal back to the data, and then the destination is the device that receives the data. So the new terms that you are experiencing here or seeing here, the signal and the noise, which we'll look later in our subsequent lecture. So yeah, let's look at what noise is. So if we talk of noise, we are looking at any unwanted signal that interferes with your transmission. So you are sending something, and then something else also comes to add to what you are sending, which you didn't intend to send it. That becomes noise. For instance, if you are talking to your friend and someone comes in the middle and starts shouting, you don't want that shout. You want your voice to reach your friend. So that shout becomes noise. And then noise are sources of electrical interference. For example, the weather can be noise, especially when you are transmitting data through the wireless media. Lightning and thunder can affect your data as it passes through the wireless media. Faulty cables, when the cables are faulty, they introduce noise into your data as it passes through the cables. And then certain imperfections in the communication device. If you talk of imperfections, no communication device is perfect, so there will be some sort of noise introduced internally in the devices as they pass data from one point to the other. So now let's look at the role of protocols in communication. So we have already explained what protocol is, that they are the set of rules that govern data communication. We've talked about some of these earlier on in the slide, that it defines how data is formatted, it defines how data error is handled in data, and then it defines how devices identify each other on the network, and then how they will act if there are errors, whether they should retransmit or whether they should drop the data. Typical examples of protocols that we will look later in our subsequent lectures are the transmission control protocol / internet protocol, the hypertext transfer protocol, and then the secure hypertext transfer protocol, the file transmission protocol, and the simple mail transfer protocol. These are very few ones here. We'll look into details some of these protocols, what they are, what they do practically, how do we see them at work on our networks. So here we are saying that devices cannot communicate if there are no protocols. Without protocols, devices cannot understand each other. And if they don't understand each other, they cannot communicate with each other, because they have to set rules before they will communicate with each other. So in this lecture, we have talked about what data communication is and why it is important. We have looked at the basic component of data communication, what makes up a data communication system. And then we have looked at for a data communication to be effective, the things it must have, and then we have looked at the three main ways through which data moves along the data communication system. That's the half duplex, the simplex, and then the full duplex. And then we have looked at a basic communication model. So someone's proposal of what a basic communication model is, which is widely accepted as a very basic communication model. And then these concepts now form the foundations of what we'll be looking at later in our other lectures. In our next lecture, we will look at how data is represented on a network. And then we also talked about signals, what signals are, and then what are the types of signals that we have, and how do they move from one point to the other. Thank you for watching. I'll see you in the next lecture.